Hi, boys and girls. It's Mrs. Atkinson. Today is Wednesday, April 15th, and today we are going to be talking about lesson 12.6. So please take out your topic 12 notes packet, and we are going to turn to the page that looks like this. Your page should have a place value chart. Today's lesson is actually pretty complicated. It is going to require you to take everything that you've learned this entire topic about decimals, about place value, about fractions and how they're related to decimals, and including money and that relationship, and kind of combine all of our work in this topic and put it to good use. We're going to be looking for and using structure to solve a very difficult word problem. So we're going to start by warming up. I am actually going to say out loud a number to you. And I want you to try to write it in the blanks in this place value chart. This is not an easy task. You need to listen. I'm going to repeat the number twice, and then we can check it and see what you wrote. Okay, so ready to listen? Here it is. Listen to it, and then I'm going to repeat it, and you're going to write it down. 7,217 and 717 thousandths. Try it again. 7,217 and 717 thousandths. All right, what you should have written is 7,217 and 717 thousandths. All right. So this portion of the number, the whole portion, was just read normally, 7,217. When we get to the decimal point, we say the word and then our decimal portion is read kind of like a whole number, 717. Wherever that last digit lands is the word that you're saying. So 717 thousandths. Awesome job, guys. All right. So today's problem is, like I said, a little bit complicated, and it is going to involve a lot of our learning for the entire topic. So the most important thing when we're presented with a challenging word problem is really to make sure that we have a firm understanding of what the question is asking us before we go into trying to solve it. So let's take a look. 3 people hiked the same 1-mile trail. All right, they're hiking in the woods, I guess. They're on a trail. There's 3 of them. I'm sure they're having a great time. The distance for each hiker is represented in the drawings. All right, I'm looking down here. I see some different distances. Okay. Show about where the 1-mile mark should be on each drawing. So they want to know where the 1-mile mark should be on each drawing. So I guess it might be somewhere a little bit different on each drawing. All right. Okay, so 3 people, they're going hiking. They all hike 1 mile, or it's all 1-mile trail. So it's out of the same hole, which is good, so I can compare them. And these are their distances, I guess they've gone so far. So I'm going to call this hiker A, hiker B, and hiker C. Okay. So let's just take a quick look. So we know here, this hiker A, hiked 5/10 of a mile so far. So it might be helpful for me to write this as a fraction. 5/10. All right. And what do I know about 5/10? Like if we're looking at 5/10, maybe you're thinking, oh, Mrs. Atkinson, that's equivalent to 1/2. And I would say, good thinking. All right. So now let's think about this. we want to know where that 1 mile mark should be. So pick out a new color for us. If this right here is a half, right, then a whole would be about the same distance. So this is at 1/2, and so the whole would be right about here, I'm thinking, right? So I think that this blue mark would be right where 1 mile should be, which would equal our whole. Right? And that makes sense. That's a half, and then another equal jump would get us to a whole. All right, awesome. All right, let's go down to our next hiker. So hiker B is also hiking that 1 mile trail, but so far she's only hiked 25 hundredths of a mile. So let's see, what would that be like in a fraction? That might help me to think about it. So 25 hundredths as a fraction would look like this. 25 hundredths. All right. That's still not really helping me. Maybe I can make an equivalent fraction that'll help me understand it. Let's use some division to make an equivalent fraction. I don't know. Let's just divide by 5. I might have been able to use a bigger number, but let's try 5. So let's see. Let's think about that. 25 divided by 5 would give me 5. And 100 divided by 5 would give me 20. All right. So I have 5/20ths. Oh, I think I can divide further. I'm going to reduce that even further. I'm going to divide by 5 again. Let's see. 5 divided by 5 would be 1. 20 divided by 5 would be 4. All right. So 25 hundredths is equivalent to 1/4. That's as low as I can go. All right. And that kind of makes sense, guys, because let's think about it in terms of money. If we know that 25 hundredths, right, is the same thing as 1/4, right? If we have 25 cents, right, 25 cents here, that would be 1/4. And I know that 4 quarters, if I have 4 of them, how much money does that make? 4 quarters equals a whole, right? 1 whole, or if I'm talking money, it would be $1. Excellent. So 1/4 is simply 1/4. So if 0.25 is 1/4 of a mile, then how much would a whole mile be? Well, let's think about that. So this is just 1/4 of the mile. So about here would be about half, right? That would be about half of the mile. And I can label that 0.5, maybe. And so that's 1, that's 2, that's half. So maybe like this would then be another quarter of a mile. And then another quarter would be like almost right to the end, I would say. So here would be my 1 mile mark. Right? And let's take a look at that and see if that makes sense. If we count our leaps, we have 1, 2, 3, 4. And that's exactly what we've divided our number line into, right? We have 1/4, we have 2/4, or 1/2, we have 3/4, and then we have 4/4. Good job. All right, that was tough. That was tough. But now let's take a look at our third hiker. This is hiker C. Remind ourselves that again, we're talking about the same whole of 1 mile. But hiker C has already traveled 75 hundredths of a mile. And again, we can use division to reduce this fraction. I am going to go ahead and divide top and bottom by 5, and I want you to take a minute at home and think about what that would reduce to. So what's 75 divided by 5? I need to do a little math. That works out to be 15. And 100 divided by 5 is 20. So I have 15/20ths. I think I can go even further. I can divide top and bottom by 5. and I can get 3/4. So 75 hundredths is equivalent to 3/4. All right. Well, 3/4 is pretty close to 4/4, right? Which would be the whole mile. So again, this makes a lot of sense if we kind of relate it to money. We know that 75 cents is equal to 3/4 in money, right? So that means that she's already traveled greater than half. So let's see, if this was, let's see, 1/4 and then a half and then 3/4. And then, so your whole would have to be somewhere like right around there, right? And we would still have our leaps to count. Ready? 1, 2, 3, 4. And the 75 hundredths is equivalent to the 3/4. This would be our 2/4. This would be our 1/4. And then right here would be our 1 mile. All right, awesome job. So the distance from 0 to 1 needs to be different for each drawing. Why? Well, because each decimal represents a different part of the whole. So fill in that word right there. All right. Now I want to explain to you guys why this lesson was so difficult, how it really involved understanding decimal place value. And what we did was we really began to think about the decimals and the fractions to show points. So we thought that 0.5 is equivalent to a half. So we figured it would be the same distance to get to the right, as it was to the left to get to that whole, right? We also learned that 25 hundredths is equivalent to 1/4. So we figured that we needed to have 4 same size sections in order to get to the 1 mile. And finally, in our third example, the third hiker, we realized that 75 hundredths is really saying 3/4. So we needed to divide that distance between the 0 and the 1, or the 0.75, into those 3 equal parts. And then we needed to kind of add one more of those equal parts to get to the whole of 1 mile, right? So a lot of complicated thinking, and we really demonstrated how we use structure by relating decimals to fractions, and that helped us be able to locate that 1 mile mark on each of these examples. All right, here's another example, and this would be our independent practice if we were in school. It says maps from 2 different ski resorts show a 1 mile cross-country ski trail for beginners. Show about where to mark 1/4 or 0.25 or 25 hundredths, 0.5 or 5/10, and 0.75 or 75 hundredths. And I wrote them over here because I want to show you that there's something that we could do that would make kind of this probably be a little bit easier to understand in our minds. We know that we have 25 hundredths. Here we have 5/10, right? But we also know that if I added this placeholder 0, this would be 50 hundredths, which is the same as 5/10. And now I really can kind of see better how these numbers relate to each other, and I'm kind of ordering them. So let's mark that. Here's trail number 1, and I want to start, I think it's easiest to mark halfway. So I'm going to mark the 5/10 first, or we could say 50 hundredths. And then I'm going to divide each half in half. So here's the half. I'm going to divide that in half. So that would be my 25 hundredths or 1/4 mark. And then this half in half, and there would be my 75 hundredths or 3/4 mark. Same thing with trail number 2. You can see it's also 1 mile, but it definitely looks different from the first example. So I can take my 1 mile, I can divide that in half. So here would be my 5/10, and then the half and half, which would give me 25 hundredths and 75 hundredths. So in short, the size of a decimal depends on the size of the whole. The size of the whole is not the same for each drawing. In order to show 5/10, you could say divide each whole in half, or you could say like cut each whole in half. And then divide each half into 2 equal parts to show 25 hundredths and 75 hundredths on each whole. And it's as simple as that. I hope that you were able to combine all of your knowledge of our work in topic 12 and be able to use structure and the place value system to really understand how decimals and fractions work in relationship with each other. All right, guys, today's work will be to take a practice test. Our topic 12 test is going to be this Friday. It's our decimal test. And so today's practice test is really going to be helpful. It is the same kinds of questions as you will see on your real test, just using different numbers. So good luck, everyone. And I hope you join me on my live Zoom call today. See you soon.